Hi friends. Today I'm going to discuss about seasons and how seasons are occur because of tiltation and revolution. So let's draw some diagrams and then discuss the theory behind how season occur in geography and on Earth and how the tiltation causes it. So first there is a uh, this is whole diagram. Let's say here it is Earth, here it is Earth, here it is Earth, here it is Earth. So why I draw four different Earth? Because it is a sun. Usually sun is very large, but because of space, I draw sun very small. So there are four different seasons are there. Basically, spring, summer, autumn, and winter. So that's why I draw four different diagrams to indicate each Earth how each Earth indicate the one season and all other stuff in between them. So here it is spring, then summer, then autumn, then winter. So before going to how these seasons are occur at this time only and why this happen, we have to first show some uh, little bit information on the Earth because Earth is tilted around 23 and half degrees east. So that's how we have to draw these lines 23 and a half, 23 and a half, 23 and a half. So when just imagine when the earth is tilted in such a way in 23 and a half degree, sun rays coming to this part, then this part, then this part, and somewhat this part. And likewise, the portion which is come under here is likely to be more projected to the earth sun's radiation, and the portion which is just hidden here are less likely to be projected by the sun's rays. So that's why here south pole, so this is south pole, this is north pole. So if we if we observe this diagram, then we can surely know that north pole at this time, north pole is summer, and at south pole this time, this first diagram, south pole should have a winter, means this diagram. So in such a way, this diagram shows autumn at world portion, spring at world portion. That's why it is called equinox. That's why it is called equinox. This is also called equinox because it is only at the north pole where sun directly throws its radiation and hot season is come here. So that's a summer, and here it is a winter. In same here, north pole suffers or 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 suffers from autumn season, and here summer season, here winter season, and here same as a spring season. So this diagram with respect to north pole, how north pole changes the season because of tiltation and because of the sun's revolution, sorry, earth's revolution around the sun. So how you can remember this simple funda: January, February, March, April, May, June, July, August, September, October, November, December. So winter, if you look at the calendar and see these dates, you can surely get that December there is a winter in our country. Winter because Earth is in a northern hemisphere. Earth is in a northern hemisphere. So December it is a winter, March it is a spring, June it is a summer, somewhat summer, starting of the autumn season, and September it is autumn season. So this is very short diagram and simple diagram. Now let's discuss. I'll discuss this topic because this is basic of the geography, like how season occur, what are the reason to be season to be occur. Like question can be asked like explain the seasonality and various parts affecting to the season because of the tiltation and revolution. So you can draw this beautiful diagram and explain each point. Then that's it. You get marks. So this is up to seasons. Now come to the Earth's interior. Earth's interior. So we know that our Earth is geoid in shape, flattened at the pole and bulky at the equator. We know that. But could we know about how inside Earth look like? How inside it is look like? Because we live on surface. This is lithosphere, atmosphere, correct? So we have to study the Earth's interior with respect to some experiments, and we have to show evidences also. So let's took some journey to Earth's interior. So I'll draw one diagram. So this is crust to 34 kilometer. This is mantle 2900 kilometer, and this is core. Again, this crust is divided into two parts. Mantle is divided into two parts. Core is divided into two parts, like upper mantle, lower mantle, inner core, outer core. Likewise, this is a one simple diagram which indicates how Earth is inside. What are the different parts of the Earth inside? Basically, crust is mostly solid. Mantle is semi-solid and solid. Core is liquid and solid. Liquid and solid. We will look upon it how and why it is so. What is the theory behind it? So let's first discuss complete detail. This is level 1 Earth interior. We will discuss now level 2 Earth interior. Means how inside and what are the different parts Earth has soil. And then we will surely discuss about other evidences why this and why this is not, other theories. So this time some big diagram. So this is, let's say, crust, and this is whole is called lithosphere. Lithosphere is about 100 kilometer. Then there is a mantle, upper mantle, lower mantle, outer core, inner core. This is upper mantle. This is lower mantle, and they have their overall ranges. So this is 34 kilometer, 100 kilometer. This is 700 kilometer. This is 500, 5,517. This is 29. So this is 2900. This is 59517. This is 76713 kilometer. So this is some figure of the Earth's interior, like crust, upper mantle. And now we will discuss about what are their states, like liquid, solid, and so on and so forth. So lithosphere, name indicated in lith means solid. So this whole portion up to 100 kilometer is a solid. If you have a surface, if you dig down up to the 100 kilometer, you nothing you found on the dear magma, lava, nothing could be arises from that point of 100 kilometer. But if you go more deeper, then there is a semi-solid. This is semi-solid, means this is asthenosphere. This is asthenosphere. This is semi-solid. This is asthenosphere. Remember, this is semi-solid and this is asthenosphere, which is upper mantle. Then there is a lower mantle. It is a mesosphere. This is solid. This is outer core, which is barysphere, which is liquid. And inner core, which is completely solid. Actually, we know about, surprisingly, why this is so, but how this is possible that somewhere in between solid and solid liquid will come. Why liquid will come? Why liquid is there? Why there is a semi-solid? Then we have to discuss about evidences of this in Earth's interior. Without that, we cannot pass a judgment that this is semi-solid, this is a solid. So before going to evidences, we just discuss about how this is in very logical manner. Let's discuss. This is 34 kilometer range. So the atmospheric pressure and the Earth's interior pressure is somewhat in balancing in such a way that this become a solid. But here if we come, then there is as we go down and down, temperature will increase. And also pressure will increase, because we know PV is equal to nRT. In our 11th 12th standard we learn about this. PV is equal to nRT. As pressure increase, temperature also increase. So if we go down, pressure increases because of molecular structure and all the stuff which is going to be the pressure, going pressure to this layer one by one. So why this is semi-solid? Because there is an inner pressure also, and the minerals which the layer have. Sorry, I forgot to tell you about minerals or composition. The crust is Cl, silicon aluminum. Mantle is silicon magnesium, and core is nickel and ferrous. So crust is Cl, silicon aluminum. I'm writing here, silicon aluminum. Mantle is SiMa. SiMa means silicon magnesium. And Nif is nickel ferrous. So this is the Earth's interior structure, their names, their composition, their pressure temperature condition, and why it's so we will discuss into the next part. Next means not next part, in some minutes. Why this so? There are some proofs also or evidences also for this. So where I'm left this, so actually this is up to the 100 kilometer. That means there is a pressure also, there is a temperature also. But because of composition of silicon and magnesium, remember one important point. Silicon maximum means there is a high viscosity, because silicon is such a element which gives a high viscous, means it is very hard to flow that particular silicon in this molten condition. That's why magnesium also give rise to this property, and combining these two property it becomes semi-solid. Then lower mantle basically mixture of SiMa, that is silicon and magnesium and silicon. So just forget that part. Just look at the distances. here 700 kilometer, there is a 2900 kilometer. So to add this temperature, just imagine how much temperature this part, this type of rocks are handling. And because of that, there is a solid in structure. So I'm just giving a basic logic like temperature and pressure. Evidences actually are way more different than this, what I'm telling. Just look hard, then that's it. Just look into the theories, evidences directly, and we could directly explain how, why this evidences, and why this structure is there because of the evidences. So let's dwell into the evidences. Evidences are also very pretty much simpler to understand, like pressure and temperature phenomena. So heading is evidences of Earth's interior structure. So first theory is earthquake. In earthquake, we can say that if we put Richter scale or seismic waves instruments, and if we measure the seismic radiation, seismograph, if we observe the seismograph, then we could easily know that where there is a much liquid, the seismic waves are traveling very slowly, and where there is a solid, seismic wave travel very fastly. So that fast and slow tell us about what is inside the earth, what is actually inside that particular core and that mantle and that crust. So first technique is earthquake. Earthquake, one phenomena. What is earthquake? Earthquake is a phenomena in which two or more tectonic plates collide with each other and gives rise to some of the fracture inside the earth and gives some magma outside. That is called earthquake, or that is volcanic eruption. What is earthquake? Earthquake is similarly, but just magma is not always magma is not found at the earth's surface. That is earthquake. So there is a minor difference between earthquake and volcanic eruption. Then second theory, waves. We can study waves. So there are four types of waves: P waves, S waves, love waves, literally love waves, then railing waves. These two are surface waves, these two are body waves. Remember, these two are body waves, these two are surface waves. Body waves means inside the earth, these waves are traveling. Surface waves means outside the earth, these waves are traveling. On the earth crust, they are traveling. That's it. And this L wave and R wave, these are most dangerous waves. Just remember, this is one. There are some facts I'm telling you. So how these waves will help us to understand what is inside the earth? What is inside earth, and how it going to help us to understand the earth's interior? So let's draw one diagram and then understand. So let's suppose this is my earth. Suppose this is my core, and there is no assumption. I am not assuming anything. In physics, what we do, we just assume some first thing and then do the experiment and check that assumption and then tell us that assumption is true or false. Assertion and reason base. But at this time, I'm not doing any assumption. I'm just clearly drawing the diagram and stating that this is core. I don't know what is inside it. This is my outer surface, sorry, mantle and crust, and I don't know what is inside it. I'm just that is my assumption. Let's say here I'm put one P waves instrument, seismograph or anything I'm putting it here. I'm just passing that waves inside the earth crust, sorry, inside the earth, that is body waves. The P waves and S waves are body waves. So that's why I'm traveling these waves. So these waves are traveling in such a way. Likewise, these waves are traveling and somewhat here, they stop. They will not go inside that core and go out. That's why scientists predicted that inside this core there is some other material found. This is the prediction. That's why we are telling that inside core there is a liquid and inner core is a solid. So this is 103 degree. This is 103 degree. If I consider complete earth as from here 0 degree to 103 degree, 100 to 103 degree. If I consider this, then this portion what I'm seeing right now, this is called shadow zone. Shadow zone means waves are not reaching here, and that only one thing I'm telling you is the reason. That's why we can predict that, and here it is a liquid, not a solid. So this is because of P waves. Just write here S wave, and then try to figure it out. S wave actually travel through this and then travel further. So shadow zone comes here. Shadow zone comes here, 140 degree approximately. These degrees are not important. No one can ask you how much degree this is started and how much degree it gets stopped. The theory is very important because S waves, I'm writing one line here. P waves travel through. P waves travel through solid, liquid, gas. S waves travels only through solid. Sorry, here it is P waves. So P waves travel through solid, liquid, gas. S wave travels only through solid. So this is the one what we can say, two statement which actually gives rise to this theory, and we can conclude that inside core there is a liquid and inside that there is a solid because of the refraction of these light waves or sound waves, sorry, because light and sound wave both have the same properties. They follow same Snell's law. And so what is the Snell's law? When the light travels from denser medium goes to the lighter medium, it changes its direction also and speed also. As it travel from solid to liquid to gas, speed will going to decrease. Speed is going to decrease. That's it. So this is two theories, earthquake and S wave. Basically they're one and the same, because earthquake also tells us about one same thing, and P wave, S wave also tells us about same thing. So that's it. And so one more important thing which I remember. I'm just increasing my speed. So Earth, whole Earth, and Earth crust. Just remember iron is there, maximum, then oxygen, then silicon, then magnesium, then nickel. This is the decreasing order of appearance, or what we say, abundantness of iron, oxygen, silicon, magnesium, and nickel. Most iron occur, then oxygen occur, then silicon occur, then magnesium, and then nickel occur. Here, oxygen, silicon, aluminium, iron, and magnesium. Just remember these 2 points. That's it. Thank you.